We're going to talk about solving rational equations. So a rational equation is similar to a rational number. A rational number is any number that can be written as a over b, which means a rational number can be written as a fraction. So a rational equation is basically an equation that deals with fractions. Okay, so first thing we're going to do is remember what an equation is. So remember that an equation is an equation because it has an equal sign. Alright, without that, it's just an expression. Previously, we were just simplifying for the sake of simplifying. Now your goal is to simplify and solve. Okay? So now we're going to be solving equations. Alright, steps you need to remember. First, you're going to factor all denominators. Find the least common denominator. Multiply every term by the denominator. And then solve for the variable in the numerator. Okay, so that's the steps you need to remember. These all kind of work the same way. Alright, let's look at an example. This is a rational equation because it's a fraction equals a fraction. So we call this a rational equation. So factor, these don't need to be factored, so all we have to do is find the least common denominator. Okay, 15 will not go into 5, but 5 does go into 15. So we're going to say 15 is our least common denominator. We can multiply this side by 3, and now we have a common denominator. So I'm going to have x minus 1 over 15 is equal to 6 over 15. Now it says multiply each term by the least common denominator. When we do that, we're multiplying by a number over 1. So this is on top, this is on bottom. So essentially 15 divided by 15 equals 1, or they cancel out. We're left with the numerator. So x minus 1 equals 6. Add 1, x equals 7 for this first one. Okay? Alright, so we can check this. I'm going to check it over here on the side. So we can check this by simply plugging it in. So 7 minus 1 over 15. Does that equal 2 over 5. We always check it with the original problem. So all I did was substitute my x in. Substitute that in for x. So 7 minus 1 divided by 15, does that equal 2 over 5, which was our original problem. Alright, so, and I put a question mark here just showing that we're just checking to see if this works. 7 minus 1 is 6 over 15. And 6 and 15 are both multiples of 3. So 3 goes into 6 twice. 3 goes into 15 5 times. So 2/5 equal 2/5. So this works. Alright, let's look at the other one over here. Alright, x plus 4, x and 3x. These have 3 different denominators, and we have to have a common denominator all the way across. Alright, so you can't just assume this x is the same as this. This is x plus 4. So we actually, I'm going to take and move it over just a little bit. So I'm going to have 2. I already have x plus 4. And I'm going to add an x. And I'm going to add a 3x. So if I add an x and a 3x, an x and a 3x, whatever I multiply on the bottom, I have to do the exact same thing on top. Okay? Now I'm going to subtract. This one has an x. So I have an x. I need a 3x. And I need an x plus 4. Again, whatever I do on the bottom, I have to do on the top as well. And then that equals, now these both have the same. Just going to use parentheses there so we don't forget we're multiplying. All right, and then this one has a 3x. So to have a common denominator, I'm going to have my 3x, but I'm going to add an x. And I'm going to add an x plus 4. Now I have x, 3x, x plus 4, x, 3x, x plus 4, x, 3x, x plus 4. They all have the same denominator. Now, no matter how big the problem is, multiply by that denominator. And it's like it's over 1. And it's going to cancel, and we're going to assume we're doing the same thing on this side. So we're going to get rid of all of our fraction. Once you get rid of the fraction, then it just becomes a normal equation, and it looks a whole lot easier. So 3x squared, 3x squared times 2 is 6x squared minus, and the negative gets distributed all the way across. So I'm going to leave the negative for now and go ahead and multiply here. 1 times anything is just whatever that anything is, so that's just 3x. And then I have to distribute here, and I get 3x squared plus 12x. And again, that negative gets distributed, so that's why I use the parentheses so that I don't forget that negative sign. Okay? Now I've got 2x, and I've got to distribute that here and here as well. So I'm going to have 2x squared, and I'm going to have 2x times 4, which is 8x. Now, I'm going to go ahead and distribute my negative since I have that there. I've got 6x squared minus 3x squared minus 12x is equal to 2x squared plus 8x. Okay? Since I'm running out of room here, I don't want to change screens just yet. So I'm going to draw a line here, and I'm going to come right up here. Hopefully, you guys can see this all right. So I've got 6x squared. I'm going to go ahead and combine that. Since I have 6x squared and negative 3x squared on the same side, 6x minus 3x, or 6x squared minus 3x squared is just 3x squared. So that's done brought up. And then I have minus 12x is equal to 2x squared plus 8x. Alright, so I'm going to subtract 2x squared from both sides because I have an equation. What I do to one side, I do to the other. So I'm going to be left with x squared here. And then I'm going to set it equal to 0, so I need to go ahead and subtract. I'm going to go ahead and subtract the 8x as well. So that gives me negative 20x is equal to 0. Now, what can I do with that? I can factor out an x. And I have x minus 20. Alright, to solve, I set each one of these equal to 0, and I get x equals 0, and I get x equals 20. Okay, now I'm going to check these and see if either one of these is a solution. Well, the first thing I look, and 0 cannot go in the denominator here. So 0 cannot be a solution. Alright, so if I check 20, I'm going to have 2 over 20 plus 4 is 24 minus 1 over 20 is equal to 2 over 3 times 20 is 60. Alright, to get a common denominator here, actually I'm just going to use my calculator to save time. So if I could punch this in exactly like it is, it should tell me if these two are equal. So I'm going to do 2 divided by 24 minus 1 divided by 20. And that gives me 1 over 30. And if I reduce 2 over 60, that also gives me 1 over 30. So that works. So this is a solution where 0 is not. So for this problem here, x equals 20 is your solution. Okay, here x was equal to 7. And we checked both of those and they worked. All right, I hope this is helpful.